Hi everyone, this is Architect Safa Siraj, Assistant Professor and Head, Department of Design, Faculty of Architecture, Planning and Design, Integral University. So the subtopic which I'll be covering today on soil is fundamentals of soil science, type of soils, principle of soil stabilization, type of stabilizers. So these all are the parts of AR 102, Building Construction and Material 1. So first of all, we should know that what is soil. Soil is a mixture of organic, minerals, gases, liquid, and organisms. Soil is the biological active porous medium that has developed in the uppermost layer of Earth's crust. Soil is one of the principal substrata of life on Earth, serving as a reservoir of water and nutrients, as a medium for the filtration and breakdown of injurious waste, and as a participant in the cycling of carbon and other elements through the global ecosystem. It has evolved through weathering processes driven by the biological, climatic, geological, and topographical influences. Types of soil. There are four types of soils: sand, silt, clay, and loam. Sand. The particle size of coarse sand ranges from 2 to 4.75 mm. Medium sand ranges from 0.425 to 2 mm. And fine sand ranges from 0.075 to 0.425 mm. The bigger particle size of the sand gives wet or dry sandy soil a grainy texture when you rub it between your fingers, and it makes the soil light and crumbly even when you try to stick it together in your hand. The practical shape is angular, subangular, rounded, flat, or elongated. The texture is rough, smooth, or polished. The sources from where we get the sand are pit sand, river sand, and sea sand. So the sand is formed by the weathering rocks, and on the basis of the natural sources, the sand is further obtained from three different sources, and these are the different three sources. Pit sand. This sand is obtained by forming pits in the soil. It is excavated from a depth of about 1 to 2 meter from the ground level. This sand is found as deposits in the soil, and it consists of sharp, angular grains which are free from salts. It serves as an excellent material for mortar or concrete work. Pit sand must be made free from clay and other organic before it can be used in mortar. A coating of oxide of iron over the sand grains should be removed. River sand. This sand is widely used for all purposes. It is obtained from the bank or beds of the rivers, and it consists of fine rounded grains. The presence of fine rounded grains is due to mutual action under the action of water current. The river sand is available in clean conditions. The river sand is almost white in color. Sea sand. This is obtained from the seashores. It is brown in color, and it also has the fine rounded grain. As it is obtained from the sea, it contains salt, which is used in attracting moisture from the atmosphere. Such absorption causes dampness and disintegration of work. It is generally not used for the engineering purpose due to its retard setting action of cement. It is normally used for non-structural purposes. Depending upon the size, the aggregate with the particle size more than 0.15 mm and less than 4.75 mm are fine aggregates, also known as sand. Classification of sand on the basis of its sizes are fine aggregates and coarse aggregate. Fine aggregates. Aggregate most of which passes 4.75 mm IS sieve and contain only so much coarser material. They are categorized into three further fine aggregates: natural sand, crushed stone sand, and crushed gravel sand. Natural sand, fine aggregate resulting from the natural disintegration of rock and which has been deposited by the streams and glacial agencies. Crushed stone sands, fine aggregate produced by the crushing hard stone. Crushed gravel sand, Fine aggregate produced by the crushing the natural gravels. Coarse aggregate. Aggregate, most of which is retained on 4.75 mm IS sieve and containing only so much finer material as is permitted for the various types described in this standard. Uncrushed gravel or stone which results from the natural disintegration of rock. Crushed gravel or stone when it results from crushing of gravel or hard stone. Partially crushed gravel or stone when it is a product of the blending of A and B, that is uncrushed gravels and the crushed gravels. Silt. Silt sediment particles ranging from 0.4 to 0.06 mm in diameter irrespective of mineral type. Silt is easily transported by moving currents but settles in still water. An unconsolidated aggregate of silt particle is also termed silt, whereas a consolidated aggregate is called siltstone. Silt deposits formed by wind are known as loess, a yellow unconsolidated rock. Sediments are seldom composed entirely of silt, but rather are a mixture of clay, silt, and sand. Clay-rich silt, upon consolidations, frequently develop parting along bedding surfaces and is called shale. If parting does not develop, the massive stone. So these are the different photos of the silt. Clay. Clay is a finely grained natural rock or soil material that, along with other materials such as stone and wood, has been used for construction for thousands of years. Clay is formed very slowly as a result of weathering and erosion of rocks containing the mineral group known as feldspar. Clay product. So clay product, we can see that clay products are used for the ornamentation purposes, also for the drainage purposes and for constructing the walls, for pavement also. The traditional houses of Kerala and other places, you may see the clay product have been used extensively. Soil stabilization. Soil stabilization refers to the process of changing soil properties to improve the strength and durability. Soil stabilization refers to the process of treating a soil in such a manner as to maintain, alter, or improve the performance of the soil as a road construction material. Purposes of soil stabilization: to improve the strength of the bases, and sometimes surface courses in case of low-cost roads, to bring about economy in the cost of raw, to make use of inferior quality of locally available soils materials, to improve the certain undesirable properties of soil, such as excessive swelling or shrinkage, high plasticity, difficulty in compacting, etc., to facilitate compaction and increase load-bearing capacity, to reduce the compressibility and thereby settlements, to improve the permeability. Components of stabilization: soil stabilization, stabilizing agents such as cement, lime, fly ash, blast furnace slag. Type of stabilization: mechanical stabilization and chemical stabilization. Thank you.